So a myopic eye would have a point, which is called the far point, beyond which it cannot focus the image on the retina, right? You would like to have a normal eye, which means that you would like to be able to focus objects that are at infinity. So the kind of lens that you want to use, as we just discussed, will be a diverging lens. But what should the focal length of that diverging lens be to correct for your problem? That's the question. So what the eye doctor is going to do when you go to his office is have you read letters from the wall without any help, any glasses or anything. And that way they're going to establish what is the furthest away distance that you can still recognize the letters. Right? That is going to determine this, which is called your far point. It will be a number, 3 meters or feet or whatever. And that tells the eye doctor what should be the F to correct for that problem, for myopia. What is the connection between those two numbers? Basically what you want is that when you look with your lenses on, when you look at an object that is at infinity, you want the lenses, the glasses, to produce an intermediate image of that object, right? That is at your far point. Because from that point, your eyes can do the rest of the job. You can focus on something that is at the far point. You cannot focus on anything further than that. So the job of this lens is going to be to take an object that is at infinity and form an image of that object at this location. Now this lens should be, it's typically very close to your eye, so what should be this distance then? We want the diverging lens to do this. Parallel eye rays, they should diverge in a way such that they seem to be coming from this point, which should be the far point of your eye. That's what you need those lenses to do, right? Then if those light rays, this is the eye over here, the eye is going to get those light rays, they seem to be coming from this point. It's placed 33 centimeters from their eyes. At this point that person would not see clearly. Alright, so it's a very easy connection between the far point and the diopters or the focal length of the glasses that you need. Yeah. So the diopter is defined, is the focusing power of your lens, of a lens, is defined as 1 over the focal length. So the diopters that you need to correct for your vision will be 1 over your far point if you have myopia. Right? We'll discuss hyperopia next class. So we were talking about correcting myopia. So the idea with myopia is, as you remember, that the eye is a little too long. So when the crystalline is relaxed, the image of an object or a faraway object is not formed on the retina, right? So if you have, that's the good thing about myopia, I'm showing there, just a second. So if you have an object that is really far away, so those light rays, in a normal eye, which has this shape, those light rays will be focused on the retina, which will be over here. But for a person with myopia, the eyeball is a little too long. Therefore, an object at infinity gets an image formed here, which is not where the retina is. So therefore, you get an image that is blurry because the light rays are not coinciding at one point there. As you start moving the object closer, well, basically what it means is that you have to have, the object cannot be at infinity, right? the object, the furthest distance that you can have the object from your eye, it's called the far point, and that far point is not infinity. It's actually, suppose that this is the far point, so the light rays coming from an object at the far point of the myopic eye will be focused on the retina. At this point, we're looking at the crystalline lens fully relaxed, so there's no accommodation. And we're doing that because if it was not relaxed, that is, if there was some accommodation going on, that means if it was squeezed by the muscle, the ciliary muscles, then the focal length of the lens would be shorter, which means that this image would move this way. If the F gets smaller, then this point moves that way. So that would make things worse, right? So accommodation doesn't help, and you simply cannot focus on an object that is further away than your far point, which is some distance, whatever it is. For me, it would be 30 centimeters or something like that. Anywhere here, those light rays do not get focused here. There's a positive thing about having myopia, which you might not be aware of, and that is that you see better than normal. Objects that are close to you, you see them better than normal. Because this is the normal point, the near point, which is 25 centimeters. For an object, for a person with myopia, you can focus on objects that are closer than that distance. The light rays coming from that object, which would normally miss the retina of a normal eye, because they would be focused behind a normal retina. Since the myopic eyeball has a retina further back, they can be focused on the retina. Being able to focus on an object that is closer to you means that you can see more details of that object. Right? So if you ever trying to figure out something that is written in very small print or something like that, and you have myopia, take off your glasses, take off your contact lenses, because you'll be able to see much better. Unless you have something else going on. If you have myopia and something else, then of course that doesn't help. But so this line over here shows you the normal range for vision for a person. For a normal person would be between infinity and 25 centimeters, which is the near point for a normal person. For a person with myopia, as we already discussed, this is too far, and there is a maximum distance, which we call the far point, somewhere here. But that comes always together with an ability to focus objects that are closer than 25. Testing, 1, 2. Turn it on. All right, so that's the situation for myopia. So how do you correct for that? Well, remember that what the real problem is that you cannot see objects that are further away than the far point, and that far point is not infinity, so that is the problem. Not really being able to see close is not really a problem, better than the normal person. So that's not what you want to correct for. So what you want to do is, if you place an object at infinity, which would the light rays, by the time they reach your eyes, they look pretty much parallel. Then if you have an object over there, we know that the eye by itself cannot focus those light rays, right? So what you want to do is make those light rays, by placing a lens here, you want to make those light rays seem to be coming from your far point, right? Light rays that are diverging in this specific way, they can get focused on the retina. So if you were able to make these light rays that are coming in parallel look like they're coming from here, so that they have that angle, the same angle over there and here, then they will get focused by the eye, no problem. So what kind of lens can take an object that is at infinity, sending parallel light rays, and produce an image that is over here, that seems to be coming out of one point? That has to be a divergent lens, right? First of all. And second, the focal length of the diverging lens must match the far point of the person, right? Because parallel light rays seem to be coming from one point, and that has to be the focal length of the divergent lens that you're using, and that point needs to be equal to the far point of the eye. So what we're saying basically is that the focal length, to correct for myopia, you need a lens that has a focal length that is, it's going to be a divergent lens, so it's going to have a minus sign, and the focal length should match exactly the far point of the person. Okay, so as I mentioned before, when you go to the eye doctor's office, what they ask you is remove your glasses if you have any, look at the letters. The lowest letter, line of letters that you can read, that tells the doctor what is your far point. And knowing the far point, it is straightforward to determine what is the diopters that you need. Because the diopters are defined as 1 over the far point. That's called the power of the lens. And so that's the equation that you will use. So if your far point is 30 centimeters, like mine, then the diopters will be 1 over 30, which is 3.3, and negative because it's a unique divergent lens. You want to use, sorry, this should say meters, not centimeters. It should be in meters. So 30 centimeters is 0.3 meters. 1 over 0.3 gives you 3.3. Yeah. What kind of lens would take an object that is an infinity and bring it close to you on this side? You want the image to be virtual, right? Because it's going to be on this side of the lens. That's the upstream side of the lens. Okay, so immediately that tells you that it's going to have to be divergent lens.